Hello, everyone, and welcome to the third installment of the CosmoQuest International Observe the Moon Night Hangouts. My name is Nicole Gallucci. I am a postdoc with the CosmoQuest project, and I am joined by Fraser Kane. Wave, hello.
Hey, Nicole.
Is the producer of Universe Today, and we have two really gorgeous views of the moon right now. From the one that's highlighted right now is from Corey Schmitz. Did I pronounce that right? Corey Schmitz?
Yes, you did.
Excellent. So he is a. Why don't you tell us a little bit about your telescope setup?
I've got a 10-inch Newtonian reflector on a Dobsonian mount, just in my backyard.
Cool.
Inside a makeshift observatory that's shared on my Google Plus page. It's kind of funny, but and then I've got a DSLR Canon T2i at prime focus that is on a homemade equatorial tracking mount that I built because Dobsonians don't typically track. Right. So I made that, and it seems to be working relatively well. So
it's gorgeous. I love it. And we're also joined right now by John Kramer. So I've highlighted his view as well. So why don't you tell us a little bit about your setup, John?
Well, it is a 8-inch Schmidt-Cassegrain Celestron C8 telescope on a computerized tracking mount, and I have actually a surveillance camera. It's a Samsung SCB 2000 surveillance camera as my imaging camera at the prime focus of the telescope, and it's on a semi-permanent sphere in the background, or in the backyard rather, and that's where I kind of do my broadcasting.
And we were just joined by Scott as well. We're getting a bit of an echo. Oh, Rachel, okay. So when you can turn your mic back on, Scott has been tirelessly coordinating observers around the globe to get to bring you views of the moon for all different time zones throughout the day, throughout this International Observe the Moon Night. And so we are really excited to have everyone. Scott, say hi. He smiled. He's waving. We can't hear him. Scott was supposed to be doing some moon observing as well.
We can hear you now.
All right. So yes, we were supposed to be observing, but we're have clouds and we have rain coming in, which is no fun. Okay. So I'm up in the astronomy room with all sorts of astronomy goodies back here.
Yay! And
take a look, Corey. Corey's got the Lunar X going on right now.
That's the one we have glorified. That's the one we have glorified.
There it is.
Okay, so what?
I think it's short-lived right now. It's only has another hour or so left on the Lunar X.
So you see, there's kind of a big crater right in the center of the image, and to the right of it is this white X, and so that's just the crater rims of two craters that are next to each other, and it looks kind of like an X, which is appropriate because all our CosmoQuest stuff has a little X. X marks the spot. Okay. And so there are a couple places where you can interact with us. If you're just joining, we are doing an International Observe the Moon Night Hangout. We have two telescopes set up right now that are looking at the moon. This is our third in a day-long celebration of the moon. Everyone observing the moon. Now. And so if you're watching on Google Plus, go ahead and leave a comment on the thread, and we will see that. Leave a comment on the YouTube page if you're watching on YouTube. And if you are watching us anywhere else and are using Twitter, you can use the hashtag #MoonHangout to get in touch with us. But people all over around the world are using the hashtag #MoonNight. If you want to see pictures of the moon from people all over the world, check out that hashtag as well. But use Moon Hangout to leave us a question.
That's really cool. So both, oh no, Corey's got the. Oh, we got some echo happening from David.
There we go.
So I've switched us up back to Corey's view.
You guys tell me what to do if you want to see another part or see the entire moon. Let me know.
Okay, cool. I hear a little bit of wind coming from somewhere. And it's like David Dickinson just joined us. Hello. He's probably setting up right now.
I believe that I have Mar Vaporum here in my telescopic view here. Gives a nice contrast to the lunar X region, which is just chock full of nice, interesting craters. This is more of a flat region with hills and valleys and such.
Yeah, so these flatter regions, the mare, are typically younger surfaces, as it's got less craters. Lunar geologists use crater counts in a region to determine the relative ages, and so this is smoother terrain is younger because it's been filled out by volcanic activity that happened later in the moon's history, whereas the many cratered highlands of the moon are a much older surface.
I'm looking in John's view there, and you can see these they're like cracks. I mean, they look like the trail that like a boulder might leave as it's going down a hill, but obviously it's way too big for that. I mean, what are those kinds of features?
That I don't know.
Zing.
Zing. I'm not sure I'm seeing it.
It's like right in the middle of John's view.
Okay. I don't know. I know we see tracks from boulders on Vesta.
Yeah, I mean, this is huge, right?
Yeah, this is a lot bigger.
This is David Dickinson here. I'm all set up now.
Hi, David.
Hey, thanks for the help. Looks like I'm getting clouds now in front of my camera, unfortunately.
Yeah.
I had a great view about an hour ago.
Yep. Fade to black.
Give it a moment here. It may pass over.
Cool.
I had the lunar X in there for just there. It's coming back out for just a second.
Oh, is that Corey speaking? Yeah. I see it. And so we think this feature will only be around since the Terminator's moving. It will be available for about an hour or so.
Correct.
So we have a question from Lewis Hill. Ooh, are there things to look forward to in exploring the moon that would require manned flight?
The robots can do a pretty good job now of observing almost anything you want on the moon. So, I mean, I think we really want to send humans back to the moon just to send humans back to the moon. I mean, that's, how do we become a spacefaring civilization without sending people to space? I mean, I think right now the capabilities of the spacecraft. I mean, look at the kinds of things that Curiosity's doing. So there's. I mean, the Lunar Reconnaissance Orbiter has done a phenomenal job of mapping out the moon in tremendous detail. Hey, we can see the Apollo 11 landing site too. Do you remember where it is, Corey?
I do. I just have to find it. I'm going to mute my microphone though because my son's out here with me.
Okay, I can see it in your view right there. It's that white dot that's almost at the very center of your view.
Yep, I will grab that. Hold on one.
I'm gonna.
There it is.
Wow.
So that's the Apollo 11 landing site. So there's that really white, that bright white feature there. You can see when he zooms out. I don't know if people can see it. So it's that really bright white spot that's right in the very middle of his view there. That's the Sea of Tranquility, and that's pretty much right where the Apollo 11 landed with Neil Armstrong and Buzz Aldrin, right?
Yeah, so that so one of the talks going on at the Franklin Institute was about moon myths, and so the speaker talked a bit about lunar mythology, but also talked about the myths that people come up with for saying, oh, we didn't really go to the moon, it was all done on a soundstage. And one of them, so that I don't know if that white spot, is that a natural feature, or is that from the dust being disturbed from the lander?
No, it's a natural.
That's a natural feature.
Yeah.
Okay.
Yeah.
Because there was one of the points that moon hoax conspiracy theorists tend to bring up is there's no blast crater from where the lunar module landed, but he showed a close-up view from under the lunar module, and you can see all the dust has been just completely blown away from the exhaust, and so you can tell that the surface has lost all its dust. It's just this bedrock that's exposed, and I thought that was pretty cool because I hadn't had that pointed out before.
So William Donahue on Google Plus just answered my question that the features are subsidence sites.
Subsidence sites.
So places, I guess it's like places where, after things have cracked and cooled, then you get these cracks in the surface at the bottom of these craters. There's a great view of some images. There's a great big crater on Mercury that has kind of the same thing. I'm going to try and dig that one up because it was beautiful.
Okay.
Yeah.
Yeah, the moon doesn't have plate tectonics like the Earth, of course, but it did undergo some cooling, and so it's going to shrink a little bit, and that'll crack up the surface.
Yeah.
And I want to say hello to Freddie. I'm showing his view of the moon right now. Hi.
How are you?
Where are you broadcasting from?
Memphis, Tennessee.
Cool. And what equipment are you using?
That is a William Optics 66 millimeter and a Celestron camera. Mounted in a mid-mount, equatorial.
Very cool.
Thanks.
And David.
Yes.
Yeah, so where are you calling from, and what equipment are you broadcasting?
I'm north of Tampa Bay here in Hudson, Florida, and I'm using an 8-inch Celestron telescope with a off-the-shelf webcam. I can probably even switch over and actually show you what I'm using here.
Sure.
Let me turn on the overhead light.
So I put up that image from Mercury. Nicole?
Yeah, I will feature that for a second.
So that's Rachmaninoff crater on Mercury.
So there's some of those cracks in the crater there. Now I'm going to switch back to David. Hello.
Hey. Let's see if I can get the camera up here. This is just a $20 Walmart off-the-shelf webcam with the eyepiece modified, hooked onto it with a 1.5-inch barrel hooked onto it, and it just hooks right in there. And I usually stream it with K3CCD tools and use Registax on it, but it's a very simple $20 setup, actually. There's no other modifications to the camera done. But there's also an occultation of a bright star in about 20 minutes for the U.S. East Coast. I don't know if anybody will be able to get it. I may try to acquire it. It's Mu Sagittarii is the name of the star. I saw it on the limb there just a minute ago with binoculars. I don't know if this webcam will catch something that faint at 4th magnitude. I mean, I can catch Galilean moons with it, and they're about 6 or 7, so we'll see. We might be able to get it. Plus, it's cloudy, too, so it may go behind clouds.
Gotcha. Yeah, I don't know how the rest of the East Coast is faring, but I am calling from Philadelphia, and it is stormy and rainy and gross, so don't know how we're doing. I've switched us back to John's view again. So, of course, you want to, when you're observing the moon, you want to great time to get it is during first quarter because it is going to be up high in the early evening when most people are outside and want to do their observing and don't want to be out at 3 a.m. But you also want to catch it when there's the most striking features are near the terminator. So that's the day-night line on the moon, and so that's moving slowly across the face of the moon. And so that's where you can see these sharply defined craters, and that's why you see that sharply defined X. And cool features like that.
There's also a lunar V, too, that you can see on the Terminator. I don't know if I can get it. I just found out. I found out about this about a few weeks ago. I'd never heard of the Lunar V. There it is, right there.
Ooh, wait.
Neat.
Oh, I see. David?
Right in the center. Yeah.
Yeah.
Yeah. That is in the Sea of Vapors right there along that area. It's just like two old crater walls that are kind of collapsed. But yeah, cool. I had never heard of the Lunar V. It was actually in Astronomy magazine a couple months ago, and I hunted it down, wrote a post on it. But I was like, it's visible right about the same time. I'm finding more lunar letters every day. So.
Yeah. Usually you're not used to seeing such sharp features. That's really cool. And
got the whole alphabet on the moon.
There we go. John's view of it as well. Yeah, you can make alphabet soup out of the moon. This is fantastic.
Oh yeah, there it is.
Yeah, east coast of northern New York is covered in rain. Rain. Oh, going back, looking through some questions. Ulysses, hey dude, is asking us, were there other considerations for Apollo landing near the poles, or was it too dangerous? I think most of the Apollo landing sites are kind of near the equator, and they wanted a balance of some interesting geology, but obviously a safe place to land. I don't know if the poles were ever in consideration. There's, of course, a lot of talk of going to the South Pole for reasons of looking for water in the permanently shadowed craters. I know that it would be an ideal place to put a radio telescope because you want to be far enough on the far side of the moon such that you're shadowed from Earth, but that you could also be able to get signals back and forth. Fraser, do you know anything else about poles?
Yeah, right. So there's parts of the moon that are permanently in shadow, and so the theory is that there could be permanent deposits of water ice in these areas of permanent shadow, and so these would be just ready-made places for bases because you would be able to.
Right.
Hold on a second. I gotta go tell some children to be quiet. Right, so you'd have a ready-made place for a base, right? Because you would have this situation where you would have there would never be any sunlight to gasify sublimate the ice that's on the surface of the moon, and so you could set up a base there. You'd be able to, extract water, and from water you can make hydrogen. You can make all kinds of stuff. So that's the thinking. But I mean, yeah, I think you mentioned, right, a lot of the places with the Apollo missions, I mean, they're really looking for safe places to land. Mm-hmm. I've wanted to show David showed his setup. I thought I'd just show sort of what Corey is kind of doing. So Corey and I have kind of the same setup. So Corey's got a T2i, which is a Canon DSLR camera, and I've got a T3i, which is sort of just the next iteration. And so what you do, right, is you take off your main lens, so you've just got the raw body of the camera. And then you can pick up a device, which is an adapter, really cheap. I got mine through eBay. I think I paid about $20 for the two parts. You get one part that that connects to your to the camera, so it's the right shape for your camera. You get the other part that's the right eyepiece size for your telescope, and then you can put them together. In theory, so now you've got your camera with its eyepiece on, and then you can take it and you can plug it right into your telescope. And that is how Corey is actually streaming his view of the sky right now. And so you can see Corey's got the view, the one right now. I don't know, do you have it highlighted? No.
I have you highlighted because you were showing.
Yeah, so if you highlight Corey's view for a second.
Now gone back to Corey, yep.
Yeah, so that's what Corey's doing, is he's using almost the same camera that I'm using, but he's streaming it in beautifully. So that's, yeah. Oh, Mike just asked where I get this telescope. This is actually my larger telescope, and I left it at my father's place. So I actually have, Katrina, my wife, picked this up at a garage sale, and for $50, and it's a Celestron 114 telescope, and it's worth about, I don't know, $400. So that was cool. Good find from the wife.
Very good find. Very good find. Sweet. I'm going to switch to John's view because we have another gorgeous mare picture to one of the smoother, darker areas. For the first time, I actually saw the man on the moon in a picture today. You know how you're supposed to see a man's face on the moon, and I had never, or human face on the full moon, and I had never quite seen it. I always see the rabbit. But one of the speakers today pointed out, and I'm like, oh my god, not only does it look like a face, it totally looks like Carl Sagan. So
you see Carl Sagan on the moon?
I totally see Carl Sagan's face on the moon in the Maria. So think about look at a full moon picture and see if you can see that. Yeah, actually, so switching back to Corey's view, if you kind of back up and tilt your head, you can see the two eyes and a nose. It's kind of a face there. Let's see. There's just a couple other questions go past. There we go. Lucille asked us, what are some questions still left in regards to the moon? What are the top 3 unanswered questions? One top unanswered question I would put, it's not completely answered, is how did the moon form? So the Earth and the moon are kind of a unique system in our solar system in that the diameter of the moon's about 1/4 the size of the Earth. Usually moons are much, much, much tinier than the planets they're orbiting, and so it wasn't simply leftover debris from the Earth's formation. What we think happened is that something about the size of Mars hit the proto-Earth, and from the resulting debris, you ended up with the moon. But you know, that's not, there are some observations that debate that theory. So how the moon formed is still sort of an unanswered question. Do you have a favorite unanswered question?
Well, I think the question is the moon still undergoing any kind of like geologic process? Any kind of does it still have a molten core? Mm-hmm. Is there, will there ever be volcanoes again on the moon? And this is still a bit of a question. And part of the question as well is, if you're going to have astronauts on the moon, will there be moonquakes, right?
Yeah.
Moonquake. What's going to happen to them if they get moonquaked upon while they're in their base? So that's still a good question. And I think trying to think, what's another good question about the moon?
Well, I think we're definitely surprised by the more modern observations, in particular that when L-Cross slammed a bit of itself into the moon and we found what they called bucket loads of water near the South Pole. I think the fact that there are volatile elements, volatile substances like water on the moon is kind of a surprise, and so there's still things that we're learning. Yeah.
So is there water ice on the moon? Is there geologic processes still going on the moon, and what was the formation of the moon?
Yes.
3 unanswered questions.
Those are our top 3 questions. Let's go, NASA.
Is the moon made of green cheese?
It's made of Wensleydale. Everybody knows this.
Is it really? Okay. So that's
what Wallace and Gromit discovered.
That has been solved. Okay.
It's Wensleydale. It's Wensleydale. Oh, Paul Stewart wants to know, Fraser, if you'll be streaming live into the virtual star party now that you have your setup.
I did some first initial images of Jupiter a couple of nights ago, and I learned there's a huge gap between my ability and my expectations. So to say that I am spoiled by guys like Corey is an understatement. Look what you got here with David and Corey and Freddie and John. I mean, they set a very high bar. So I'll start with the moon, I think. But part of the problem as well is the motor drive on this telescope is pretty cranky. So I don't think this telescope's going to be with me for a long time. I think
It's a learner scope. It's a learner scope.
It's a learner scope, yeah.
You can totally do that.
It's pretty spiffy. You align it, and then you say, this is where Polaris is, and this is where Arcturus is, and then it will then go to any object you want. M17, it just moves. Except that it locks up within about 30 seconds and then requires that I reboot it, and then it's completely lost all of its alignment and I have to start again. So I've been hand guiding it.
That's always fun.
Yeah.
I say that with no sarcasm whatsoever.
Hey, Fraser, hand guiding is not that bad.
Yeah.
That's why I built my mount, right?
Yeah, exactly. Yeah.
All right, well, I'm gonna have to pop out for a little while.
Okay, thank you, Corey.
So,
it's a beautiful
one more view of Corey's moon.
Very cool.
Your moon, all yours.
My seeing is actually getting extremely awful right now. If I zoom in, you can see.
Kind of the same here in Florida right now, too.
Wow. So what you're looking at is the turbulence of the Earth's atmosphere distorting the view, which is...
That's the worst I've seen when I've been out with my telescope, I think.
That's pretty bad.
John's is really crisp.
Yeah. So anyway, thanks, guys.
Thank you, Corey.
We'll see you tomorrow night, Corey.
All right, let's pop back over to John. Yeah, John's got great seeing.
Fraser, I'm going to try I'm going to try to get that 4th magnitude star, so I'm probably going to go black for a moment while I try to acquire it in the eyepiece and then put the camera back in.
Okay.
So we'll see. I don't know if we'll be able to get that occultation. It's about 15 minutes away here. I'll give it a 5-minute try.
So there's an occultation happening tonight?
Yeah, for the U.S. East Coast and the Maritimes. It's Mu Sagittarii. It's a 4th magnitude star. With the binoculars, I can see it on the limb of the moon right now. I don't know if I can get it in this camera or not. It's going to be a little tricky to do.
Well, you're going to have to mess with the brightness, right? What we find is that if you...
I'm going to have to crank the brightness all the way up, and then I'll probably have to put an eyepiece into the telescope, take the camera out, find it visually, and then put the camera back in and try to at least get it refocused.
Have fun with that. I mean, we find the difference in brightness between Jupiter and the moons are so great that you've got to, significantly change the brightness of the telescope. So
I can get the Galilean moons in their 6th or 7th magnitude, so I should be able to get the star. The tricky thing with this tiny field of view is going to be to find it. It's
just getting them at both at the same time, right? You're going to get the moon as a bright nova, nova.
It's on the dark limb of the moon, so you probably won't even see the moon through the camera.
Okay, yeah, that's better.
That's at least on the dark limb we should see it go in.
Oh, yeah, that'll be cool.
Yeah, we had I don't know if you saw, we did an occultation of Jupiter and the moon a few months ago with Ahmet out of Turkey, and it was just amazing to see Jupiter slip behind the moon and then pop open on the other side. There's Scott.
Hey, Scott.
This is Scott.
You found a more permanent connection?
Yes, I'm on my laptop now.
Yeah, the Nexus 7 isn't quite ready for prime time as a mobile broadcasting device.
Not quite.
Neither was my phone. I have yet to see how bad that video came out.
Oh, epic! Have a beer.
Was it?
It was good. You did a great job.
And we had a little helper, so the little girl who did the balloon demonstration, her name was Abby. I thanked her afterwards. I was just looked at her father and we're streaming live on the internet right now. Can I show her? So she was
Let's exploit your daughter for science.
Yes, yeah. He was like, sure, whatever. It's fine.
David, your sky looks like my sky.
Well, he's going to try and capture he's going to try and broadcast the occultation. So
I actually have the camera out of the telescope right now, so it's I'm looking for I have the star in the eyepiece visually, but it's still kind of cloudy here. I don't know if I'm gonna. And also, if you hear a noise running here, it's me running a hairdryer to clean the fog off the front of the telescope.
I thought that was wind. That's awesome. All right,
so he's doing his hair.
I'm going to do a quick station identification. You are watching the International Observe the Moon Night, Part 3, right, Scott? Part 3 of our broadcast series. We are celebrating the moon. Oh, I hear it now.
That's me. Here, I'll turn that off for a sec.
Okay. We are celebrating the moon, which is such an important part of humanity's history and culture and observing, and it is a pain in the butt for optical astronomers all over the world too. But we are now celebrating its presence and observing it from all different time zones all over the world. So we are doing our U.S. time zone broadcast now. We have several views of the moon. We have the one I've got focused right now is Freddie Diaz, and we also have one from John Kramer. And we have David Dickinson as well, who will be hopefully showing us an occultation of a star by the moon, a 4th magnitude star. Also joined by Fraser Kane, who is the founder, producer, and mastermind of Universe Today and a whole bunch of other stuff, and Scott Lewis, who is a tireless, awesome hangout producer, volunteer, observer, outreach awesomeness.
Awesomeness.
Is apparently also
I'm putting this on my
studying
business card, I think.
What, mastermind of everything?
Mastermind of everything, yeah. Dread Lord.
Yeah. Our Dark Lord Fraser Kane.
Dark Overlord, hail. I'm Nicole Galucci. I'm a postdoc with CosmoQuest, where you can actually help us map the moon's surface. We have a couple of citizen science projects. Check out Moon Mappers and Vesta Mappers. You can help us map out geological features such as craters and boulder tracks and all kinds of cool stuff like that. I am sitting from my boyfriend's apartment in Philadelphia because I'm visiting and it's cloudy and it's sad. But I was at the Franklin Institute earlier where they were doing some daytime activities celebrating the moon. And if you want to ask us a question, leave a comment on the on Google Plus where this Hangout is being broadcast, or on the YouTube page where this is being broadcast, or use the Twitter hashtag MoonHangout to make sure we see your question. But note that people all over the world are using the hashtag MoonNight as well to share their views of the moon. So go ahead and drop in a moon question for us.
And I'm going to run, guys. So, okay. But I just wanted to thank Scott. I mean, you've been tirelessly working for the last, not only just like this whole day, I don't even know the last time you slept, but I mean, you've been organizing and coordinating this thing for the better part of a week now, while you're attempting to complete your astronomy degree. So I think, mad kudos to you, buddy. You've been doing a great job. And I mean, how many astronomers have you actually gotten to stream the moon in the last 24 hours?
Across the world, I think 7 others besides what we've had here in the U.S.
So 11.
Between Australia, New Zealand, Malaysia got clouded out. We had Turkey. We had 2 from Denmark.
Fantastic.
It's been awesome. It's been a great experience, even though I don't get much sleep. I am wired on a lot of coffee and adrenaline right now.
Yeah, I can see it. It's even twitchy. So congratulations, man. I mean, this has been a really epic night, and I hope the International Moon group really appreciates the additional science and outreach that's happening. You've done a great job. So I just need to plug one thing, which is that we're going to do our virtual star party tomorrow night around 7:30, hopefully with more beautiful moon and other deep sky objects. So
7:30 Pacific?
7:30 Pacific-ish.
Okay.
10:30 Pacific, 10:30 Eastern-ish, and we've got some. There's an event on my stream, and you can sort of stick it into your calendar, and you'll probably see a lot of the same people. Oh, you want me to? Are you gonna do a demo of the Moon app? Sure. So we created an app that shows the phases of the moon, and so you can see here. You can actually sort of swipe it back and forth, and
yeah, there we go.
Yeah. Like that?
Look at that. Real time.
Nerds unite.
Well, that's fantastic, yeah. So we created that, and we've got that on Android and iOS, although the iOS one isn't as sweet as the Android
another
one.
Android one.
Yeah, but you can, if you go to universetoday.com, there's a link on the right-hand side, and you can follow it and get your own copy of it. So 99 cents. Thanks, guys. I don't want to log roll too much, but,
We'll do it for you. That's all right.
You deserve it. Do it.
Our evil overlord.
Cool. Right. Fantastic.
Bye.
Great job, guys. And thanks David and Freddie and John. We'll see you guys maybe tomorrow night.
All right. See you, Fraser.
Excellent.
All right.
Bye, Fraser.
Bye.
So Freddie sent
bye.
us a picture of his setup, which is slowly opening in my browser. Ooh, here we go. Yeah. And I will screen share this. So let's put Freddie's moon in front and center. And screen share. My laptop is dragging because it's 3 years old, and I just put
You
the
should
new
take your laptop
OS.
off a leash and stop dragging it. That's my
that's
scientific opinion right there.
So there is Freddie's setup. Is there anything you want to tell us about that?
Well, that was taken earlier today, when I was testing alignment with the sun. So you see that it's a solar filter on top of the telescope. But that is basically what is running now without solar filter, of course. It's a 66 millimeter refractor and a Celestron webcam.
Cool, very cool. And take that down. So Scott, since I missed most of the earlier Hangouts, have there been any points about Moon Knight that you want to share, or anything particular you want to plug?
Everyone's been awesome. I mean, it's been phenomenal being able to hang out not only with astronomers from across the world, which how often can you really say that? I was hanging out in Turkey looking at the moon, but I've literally hopped the globe in the last 18 hours, and it's been a great experience. We've had a lot of phenomenal questions and comments from people either on Twitter, on Google+. Whether it be common folklore that we're taught at an early age about what the moon is, if it's made of cheese or not, the man on the moon, the bunny, and actually, believe it or not, I've never seen the man in the moon before. I've never seen that man, and Pamela showed me early this morning, at like 1 in the morning. No, you see, this is how it's a man, and so I'm 28 years old, and I saw the man on the moon for the first time. So. Win. But no, honestly, there's just been some phenomenal questions. I mean, we had someone ask about libration, which made the astronomy supplemental instructor and me get all excited. I'm like, libration is awesome, because we don't think about it. Not the same as
libation. Do not get those confused.
That happens after the Hangout. But the libration is the wobble. We see around 59% of the moon through the month. So at each point we see 50%, but since it's wobbling, we get to see around that edge because of that little tilt that it does. So every month we actually do get to see 59%. And if you have that app that we're talking about, there's a simulation, not the most completely accurate one, because Fraser just told me earlier.
Yeah, he told me too.
But
they're working on it.
It still gives you the idea of what the moon is doing, that we do get to see more of it than just the 50%. It's not just what we see in the far side of the moon. We do get to see actually around the corners of this sphere, and it's awesome.
Yeah, and this is just kind of an instability, right, in the gravitational pull between them. So they're not. So the moon isn't. So the moon is tidally locked, but it's not perfectly tidally locked. It's that little bit of wobble that gives us a little bit more.
Right, because the mass is not evenly distributed across our satellite. And another great question that came up early this morning was someone did ask about the synchronous rotation of the moon, which again made me so excited, because yes, it does rotate. It has to rotate. That's why we're always looking at that one face of it. But that's because there's that mass that's dragging there, and so it's always rotating around with the Earth. And again, fantastic questions from people from across the world, and it really did underline the fact that we are all sharing this moon together, regardless of where on this blue rock we were born. No matter what we were raised to believe, what nationality, color of our skin, whatever political boundaries are between us, we are all able to look up into the night sky and share this event, just looking up at the moon and being curious and wondering what's going on.
That's so beautiful. I love it. So I'm going to poke back over to David and see what he's looking at.
Yeah, I think I'm going to.
Any luck with the occultation?
Yeah, I can see the star visually in the eyepiece, but with the camera, not so much. I think the clouds are just starting to cover it. It's too bad because it's right there. But with this camera too has a field of view about 10 by 10 arc minutes, so and it's kind of fixed right there. So it's I have videoed occultations, but fortunately the camera I use for that won't stream live. So and we're getting clouded out again. So some other locations up the East Coast. I mean, anybody with binoculars should be able to see it.
All right. So you hear that? Anybody on the East Coast who's not clouded out, which seems to be not many people.
Not many people. I swear the clouds were following us across the globe. We had 3 or 4 astronomers that were clouded out over a 24-hour period, and now where I am at, we canceled our outreach just because of nasty cloud systems coming in.
Yeah, we had thunderstorms. Yeah, is that Freddie?
It's a question for David. Do you know where should I look for? Maybe I have more luck than you trying to figure out where they start with the camera.
If you're looking on the face of the moon, if you're looking on the dark limb of the moon, the star is at about a 10 o'clock position.
Okay.
You think of it as a clock face concept. It's on the dark limb. You're probably going to have more luck seeing it go in on the dark limb than come out on the bright limb of the moon because it's only 4th magnitude.
Okay. Okay. Well, if you don't mind, I can try to pick it up.
Where are you located at?
Memphis, Tennessee.
I think
it's to the west.
Memphis. Yeah, you're in the shadow. I don't know how to share this link here, but I've got a.
Do you have the chat open? Our internal chat for the Hangout?
I can turn it up. Okay, I have a link right here of the map.
Oh, okay.
There it goes.
I will copy that link out to the public. I think I can do that.
I have seen the moon occult Antares. I've seen it occult Aldebaran in the daytime before. Spica, there's a series of occultations that it did occult Mars actually a few days ago from South America. A friend of mine down there did see it, but they're always kind of cool to watch. And double stars like this are kind of cool when they go in. This star is a very close double, so you may see it actually wink out stepwise when it goes in. It's a spectroscopic binary, so
cool.
You may see it wink out. Antares was a very cool one. I've got a video on YouTube of that I did a few years ago.
Very cool.
They usually come in cycles where the moon can go over Regulus, it can go over Aldebaran, it can go over I don't know if I said Arcturus, that's not correct. It can't go over Arcturus. Mm-hmm. But it usually comes and goes in cycles where it does that over a certain we're in a very the moon's path is very ecliptic like here in the next few years. So it's going toward a more shallow path in 2015. And then we're going to have a very high path in 2024, I believe it is. Follows the Saros cycle of about 18.6 years.
Right. Same thing that drives the cycle of solar and lunar eclipses.
Correct.
Cool. Pop over to John's view. Looks like we're scanning a different area of the Terminator. More of those funky linear features.
We are just enjoying the wonderful view of the Terminator. Yeah. I love scanning this area. There's so many. Look at the way the hilltops or the mountains there just cast those long shadows. It's just gorgeous.
You can see the ejecta around one of those craters, a little to the right of center. It looks like you can actually see the ejecta just out onto the surface from the impact.
There you go.
That's my scientific term.
I like it.
Scott, I see you talking. I don't hear you.
I'm talking with some of my students here.
Hi, students.
Nicole says hi.
I can see how the lunar X has changed just in the past couple hours. In a few hours, it won't be as prominent anymore.
Is this the V we're looking at, or the X?
The X is right there, just above center on mine. It's a few hours ago.
There it is.
A few hours ago, it was all in shadow around the base of it, and I took a quick series of photos of it. And probably in a few hours from now, it won't be as visible. You'll see it, but the base of it won't be in shadow anymore. The sun's just starting to rise on those ridges right there.
Right. So you can imagine a sunset and a sunrise on the moon is a lot slower, so like 30 times slower than a sunset or a sunrise on Earth, because a day on the moon is a month. So it's got to be really spectacular to, or just boring. I don't know. I don't know what 30 times slowed down sunset would look like.
Slow.
Hi.
It would look slow.
It would be slow. I'm trying to decide whether I would just love it or be frustrated. I'm not sure.
I think, I don't know. Everyone think, it'd be romantic, but after that long, really, like, come on, go down, please.
Because I'm always surprised at the speed of a sunset.
Yes.
And rarely sunrise, because I'm never awake at that time.
Unless you're up all night to watch it happen.
Right.
Yes.
I dragged myself out of a tent to watch sunrise at the Grand Canyon, because that you can't miss.
Right.
But other than that, no way you're getting me up that early. Ooh,
so I had a question for our astronomers. I've been asking throughout our multiple hangouts is, do you guys remember the first time you looked at the moon through telescope or binoculars? And so it's transformed from that silver disk up in the sky to actually something with features. Did you guys have any crazy experience? I know I did the first time I got to see it in a more three-dimensional light where you're actually seeing terrain as opposed to just a silver disk.
I had a little 45 millimeter Newtonian reflector when I was about 8 years old that I got for a present. Probably the first thing. It was a terrible telescope. It was a toy, but you could see craters on the moon and things like that. It was probably about all you could really aim the scope at because the field of view was so narrow on it. But I do remember it being pretty impressive. And I got a refractor when I was a teenager where you could actually see the rings around Saturn and Jupiter and the moons and the Andromeda Galaxy and things like that. And it definitely is transformative to see those sorts of things.
Yeah, it opens your mind to the universe, literally. I mean, we can look up and see little points of light in the sky. It depends on where you live. In LA, you see maybe 3 points of light in the sky. But it turns it from being this black canvas with a few pinholes to you're able to see other galaxies, and you're able to see that contrast. There is something immensely awesome that's out there, and we're able to traverse it with our telescopes and see what's actually out there.
It amazes me how many people don't know you can see the moon in the daytime.
Yeah.
I always point it out to people when I can, in Venus too. Venus isn't too hard for most people to see, especially when it's very near the moon. About a week or so ago, when the moon was a very old crescent, it was very near Venus, and it's always kind of cool to see.
How about you, Freddie? Was there a moment, do you remember looking at the moon for the first time through some optics?
Yeah, it was with binoculars, and it was in 2005.
2005, so fairly recently.
Yeah, that's the same year I went to an observatory back in my country, Venezuela. And I went to an observatory, and I said, okay, this is it. I'm going to get into this. And that's when it started, and I'm still going.
It is an addiction. I think it's a good addiction. It is. But it is. It will drain your wallet, too, if you get too addicted.
Yes, you got to be careful.
How about you, John?
I would say it was probably back in about 1988. My grandmother bought me a Celsi 4.5-inch reflector, and that scope really opened up a lot of things as far as observing the moon. I was just amazed with everything that you could see. Craters. I've always loved, like I said, this Terminator region. It's just beautiful, So. I don't mind waiting around for when the moon comes into the view. You just get to change up from looking at some deep sky objects. Now you can go ahead and enjoy the beautiful moon. So I like it all.
Absolutely. Nicole, how about you? I know that you deal with radio light now.
Yes, I do. You can see the moon in radio. Yeah, I grew up in one of those places where you can only see like 3 stars. So the moon being one of the few things you could see. I remember I have this memory of when I was 5, and we had this really crappy, cheap little red telescope. It was like this big, right? And the tripod was like this big. So we put it on the hood of a car and looked at the moon because it's the only thing you do. And it was a neighborhood of like townhouses with lots of young families and little kids. So all the kids came over to look through my telescope and look at the moon. And that was one of the things that made me decide I wanted to be an astronaut. And then I went and then somebody told me, well, to be an astronaut, you should be a scientist, because I think they realized that I was not military pilot material, even then. So I said, okay, I'll be a scientist. And yeah, 23 years later, still not an astronaut.
Now you're a postdoc with the Most Rock.
I'm a postdoc with the Most Rock. That's my title. That's my self-imposed title.
I will make business cards for you with that. That would be awesome.
We just printed up business cards, too. We're going to have to make a new set. We have to give them all away. What about you, Scott?
I think I was 7 or 8, and it was I think it was at school, and we just had some event. I didn't really know why. We were going, and I remember seeing the moon literally transform from being this, before compact, no, maybe compact discs were around then, but being a CD in the sky, to being, you can see that it's actually a sphere, and there is some geology going on, and you could see the shadows of these craters, and like it really transformed just the way I've thought of that object. And it's amazing on looking at different things and how just looking at it with your own eyes, it literally transforms the way you think about it. Same thing for Saturn, actually, too, is, yeah, we see pretty pictures of it, but the first time you get to see those rings, it blows your mind. So, yeah, I was around 7 or 8, and I never owned my own telescope. I still don't own my own. I have binoculars, and I use them all the time. I have access to telescopes, and I've got 12 in the other room over here. So I just,
nice one, by the way.
Yeah, so like, yeah, why do I need to buy them? I've got access to these.
Yeah. I didn't pull out my telescope for all of grad school because I had access to a 6-inch Clark refractor from the 1880s and several, 10-inch celestrons in the lab. So I was like, why take out mine?
Right.
So, yeah.
I can abuse somebody else's equipment. This is awesome.
We have a couple questions. Hamant Kumar asks, what about the fact that the moon, when in front of the sun, is the perfect size to eclipse it perfectly? And that's amazing. And how is that? How and why? Usually the moon and the sun are about the same angular size in the sky because the sun is a lot bigger in reality, but it's also a lot further away, and it works out so that they're about the same size.
It's around 400 times. So the sun is 400 times larger than the moon, but the moon is also 400 times closer to us.
Right.
So because of that, it just, every once in a while it lines up perfectly.
Yeah.
Like actually, it wasn't quite perfectly back in May. We had our annular eclipse. But yeah, we get some amazing instances where we get to see these eclipses, but we know it's not with all eclipses because we just had the Phobos eclipse happen from Mars, and yeah, it just looks like this little chunk going across the sun. So I think it's really fascinating that our moon just happens to be 400 times smaller but 400 times closer. I think that's awesome.
That's only in our current epoch, though. I believe it was about with the recession of the moon, it wasn't until about 800 million years ago or so. I calculated this one time, but I could be wrong. It was about 800 million years ago that the moon actually, before annular eclipses could occur, because the moon was actually too large for it to not quite cover the sun like it does during an annular eclipse. And about 800 million years or so from now, we're not going to have total solar eclipses anymore.
That sounds about right. I think that sounds about right, because the moon is slowly moving away from the Earth. It's actually changing its distance, and so yeah, we happen to live in a it's a coincidence that we live in an epoch when total solar eclipses are possible, and that we have that size distance set up so that they match up. But there are things that happen that are coincidences. It would be more weird if coincidences didn't happen, right? Of all the things that could line up, every once in a while something interesting is going to line up like that.
Right.
So we are lucky people for that.
I didn't know until the annular eclipse earlier this year that annular eclipses are actually more common right now than total solar eclipses. It's by about 40%, I believe. It's not by much, but statistically they're slightly more common than total solar eclipses. I would have thought it the other way around, but I was talking to a friend of mine about that, and we actually studied it a little bit, and it's like, yeah, they are slightly more common.
That's interesting. I did not know that.
Yeah.
I know we have a total solar eclipse happening in 2016 that's going across the continental U.S. 2017.
Yeah.
Okay.
Yeah. And I think we're already tentatively planning on going up to Oregon for it.
No, you should come. You should come to St. Louis because it's going to be 30 miles from where me and Pamela live. You should come hang out with us.
All right. Well, you pay for my flight, and I will be there.
All right, dude. Who knows? Maybe I'll get a salary raise by then.
There you go.
Fun doingo! Okay, we have another question that's not moon related, but it is astronomy related from Emmanuel Data. Since everything is in constant motion, is it possible we'll ever observe the light that left the Milky Way billions of years ago? I think we would need to be in a curved universe for that to be possible, whereas every measurement that has been taken indicates that we live in a flat universe, and so the light's just going to go out and out and out and not come back on us. Scott, do you have anything more on that?
I believe that's correct, and okay. I think a really good book that it's actually recently come out, I believe in February. It's called The Universe from Nothing, and Professor Lawrence Krauss actually goes into what we mean by a flat or curved universe. And because that's a geometry we don't typically think about in our everyday lives, but he does break it down into bite-sized morsels to digest what we're talking about when we're talking about a flat or a curved universe. It's kind of crazy when we think about it. You have to do a lot of calculations, but also comes down to trigonometry as well, which is awesome. So yeah, it's a really good book actually. It's not completely full of jargon, so it's not something that you typically understand. It's fine because he does break down different concepts so you can understand it as you move along. So I like that book quite a bit, and it will help with understanding the whole light aspect.
What's the name of the book again?
A Universe from Nothing by Professor Lawrence Krauss.
Cool. Who is now in Arizona, right?
Yes, he's at Arizona State University.
Arizona State, yes.
I actually physically bumped into him at TAM when we're at lunch. When you and I were at lunch, he was right like 5 feet away from us, and I was backing up and bumped into him.
I think I remember
that. Totally by accident.
Oops. Stepped on an astrophysicist. Oh, so we have a question from Samir Hariri. Can you calculate the depth of a crater from shadow length? I think if you have... Let me think about this.
The depth of a crater from the... Well, we also have the ejecta, so it's going to depend on what the geometry is on the inside, because we could have had different material on the top and the bottom that could have been ejected, so you could actually have a deeper pit in the center than on the outside.
Right, and you'd have to know the sun angle, which we can figure out.
I think it would take just a bunch of different images from LRO from different times of the lunar day, so we could actually see it from different angles of the sun being put down, and I think that way we'd be able to measure it out.
That ties into libration you were talking about earlier too. Is these regions we're looking at now from each lunation, like say at the next first quarter moon, they won't look precisely the same because the shadow angle's different.
Right. And so it's a good thing that we have LRO making these multiple passes, the Lunar Reconnaissance Orbiter making these multiple passes and taking pictures during different times of day for different spots on the moon.
Yay, LRO!
I think that's a good question to ask on our Moon Mappers forum on CosmoQuest, because we've got a couple lunar scientists who could answer that one better.
That's actually a really good point. For those that don't already, please do go to CosmoQuest.org, and you can participate in actual scientific research on either mapping the moon and features and craters on the moon, but also do ice investigators for Kuiper Belt objects, so out towards Pluto, and also our newly found asteroid mappers for Vesta that just data that came back from the Dawn mission. But yes, on the forums there, which recently merged with Bad Astronomy and Phil Plate's Bad Astronomy and Universe Today. But you can ask questions, and the scientists themselves are on the forums, will answer your questions, and if they don't know off the top of their head, they will do the research and get back to you. They're very good about that. So it's even more reason to find something awesome, be confused about something, and ask that question and find something else out.
Well, that fourth magnitude star is no more. It's behind the moon. So it's still there.
It's destroyed completely.
Yeah. So it's I took a look with the binoculars and I couldn't see it anymore. It may be visible from some other locations, but about half an hour from now it will come out. But it'll be on the bright limb of the moon, so it'll be tougher to see.
I thought when you said it was no more, I thought Mike Brown started going after stars, and
it's no more in a visual, like apparent sense.
Hey, I thought it was interesting, Nicole, that I think we mentioned ejecta before. I got Messier A and B here, which are those two small craters that you can see the long ejecta, almost a straight vertical line coming out from them.
That's cool.
And then you have, on the other side of that, you have almost that wedge-shaped ejecta material, much, much brighter. I think that crater is Proculus or Proclus, something like that. I'm horrible with pronunciations on some of these, so I apologize. But anyway, I thought I'd share that view.
Well, and it's really interesting with that. You see that albedo, so it's really bright, compared to the rest around there, which is showing that it's a lot younger, or relatively younger than the rest of it. And by young, we're talking like 300 million years. So, but in 4.5 billion, that is pretty young. So we get to study and take a look at the contrast of the brightness from these different the geology that's going on there, and to learn more about what's underneath the surface. So an impact could happen and throw up two different colors or two different types of ejecta just based on what's on the surface, and if it had enough force to actually throw up more of the rocky surface underneath.
Yeah, there's a cool way to demonstrate that in your kitchen or outdoors, wherever you can make a mess. If you get like a shallow pan, like a shallow cooking pan, fill it with like an inch or so of flour, and then dust some cocoa powder on top of it. And that can simulate the moon's surface and some different layers of regolith and other moon soil. Soil's not the right word, but moon dust. And you can throw marbles at it, you can throw bouncy balls at it, drop them from different heights with different speeds, and see that the craters it leaves behind. And you can clearly see when you have those two different types of material, you see bright ejecta rays left over from the material underneath. So that's a good demonstration to understand, what crater ejecta looks like. We did some of that at the Franklin Museum. We had a couple of other demonstrations. We made, this is what Tim made. He made a sun, earth, and moon system. So using those little pins that you keep, I guess, documents together with. Yes. And you can make the moon orbit the earth, and then
totally
the whole thing
scale,
orbit
kids.
the sun.
Totally
Not
scale.
Even close to scale. Not even remotely. And the sun isn't actually pointy, but they made you cut it out pointy anyway.
My sun is pointy, okay? Don't judge my pointy sun.
All right, we have a new observer, Mark.
Hello.
What's up,
Hello.
Mark?
Can you hear me okay?
Yes.
Yeah.
All right, great. Sorry, I'm at my astronomy club's actually public observing event.
Awesome.
So I brought my laptop and my cell phone and my telescope and everything out here. And
you're leaving your moon behind you.
You're drifting.
Hey, Deepak, to the right.
Rotating. Moon, exit stage right.
Oh, he just exited. Okay.
He just exited completely.
Critique my astronomy.
Greatest thing ever is to just imagine that. I don't know. I'm just very excited right now because you can imagine the Earth's rotation when you're looking at a telescope that's not properly tracking, and you can just watch the Earth rotation, which you can't otherwise feel. Okay.
Yep, sorry, I'm back.
There he is.
We missed you.
He's
Welcome
drifting.
back, Mark.
He's drifting.
Yeah, so unfortunately I had all of my equipment hooked up to a battery, and when I turned my laptop on, it tripped my inverter. And so I had to turn everything off, and it lost the alignment on my telescope. So I figured I would be better off just kind of guiding by hand here instead of going through the effort of realigning.
I've been doing a little bit of that too.
And I can tell you, Mark, I have done a hangout having to manually track the entire time. The annular eclipse is when I could not.
Oh, I remember that.
Yeah, it was ridiculous. But you can do it. I believe in you.
I've done it. Well,
I did that for a public night once, and I had to keep it on Saturn the whole time because otherwise I wouldn't know when it wasn't on object. Because if the people didn't go, oh, look at that, then I knew it was
right. It's black sky.
Yeah. If they went, oh yeah, I think I see it, then I knew they were lying and that it had drifted.
Mine's only on a very rough polar alignment, so I got to kind of tweak it every few minutes or so. I set it up in the daytime, so I just pointed it like with a compass, so it's not on a very precise north.
Gotcha. But I love it. I can feel the Earth rotating.
Yeah. So
it's just to prove that it's real and live. That's why I'm doing this.
That's right. So, Mark, we've been, throughout all of our Hangouts we've been asking the astronomers if they remember the first time that they looked at the moon through some optics, whether it be telescope, binoculars, and did it have an effect on how you thought of the moon?
That's a good question. I don't know if I remember the first time I looked at the moon. I remember the first time I looked at Saturn through my own telescope, and that was only a little over a year ago. And it just blew my mind, and, when my wife was mad at me for me spending all this money on a telescope, and I'm like, look, you can see the rings on Saturn. That's awesome. Look at the moon. I can see the craters on the moon. And then she's like, all right, well, maybe you didn't waste all that money.
So that's only a one-time use of when she's mad at you. I don't think you can here, I know you're mad, but let's look at Saturn and it's okay now, right?
It was only for her being mad at me at the telescope.
Oh, okay.
When she's mad at me for other things, I have to do other stuff.
Right. And if it's a little loud, because we are still having people show up for our events, even though it's canceled, because they are awesome. So say hello to the peoples over here.
So are you over at SETI, Scott, or where are you at?
I'm not at SETI. Oh. No, I'm at my college campus, Citrus College in Glendora.
Gotcha.
Yep. No, SETI is much, much north. I'm in the LA area.
Yeah, and that's up in San Francisco.
Yep. Mm-hmm. They're associated with Berkeley. At Hat Creek Observatory is where the Allen Telescope Array is.
And we've hung out with SETI a few times. They're really good people. We have a lot of fun hanging out with them. So hi, SETI.
Hi, SETI. Yay, radio telescopes! I know there's optical SETI too, but let's be realistic here.
All right, I've got some dramatic clouds coming in front of the moon, so.
Okay, dramatic. Let's watch the drama. Oh, I just got the end of it.
All right, Mark, howl like a wolf.
Oh.
There you go. Beautiful.
Nice.
I checked earlier today to see if there was any transits of the International Space Station in front of the moon from any locations. Unfortunately, they're all down toward the southern hemisphere for the next couple days. That would have been kind of cool. It's really quick to see. It's like less than a second when it goes in front. But and we'd need a wider view than I have right now. We'd need like a full disk view to see it. But.
Right. That I have never seen.
I've seen it transit the sun once, and I caught it with the camera doing it across the moon. But when I watched it go across the moon, I didn't see it with the naked eye when I watched it with binoculars. But I did see it when I went frame by frame over the video. I saw it afterwards. It's when it does a shadow pass and it's not lit. It's very quick. It's like less than like half a second when it goes in front of the moon. And you don't see it like you do when you see an ISS pass when it's a bright star and it comes up over the horizon, unless it happens to be illuminated at that time. A lot of times it comes up and it's just in shadow, so you don't even see. You just see the outline of it when it goes across the moon or the sun.
Cool. Yeah, I've seen it go across as kind of a star. I stood outside on campus at UVA and just stared watching, and students will walk by and be like, "What are you looking at?" And I'm like, "Space station with astronauts, look." And they're just like, "What, you can see that?"
Yeah, a lot of people don't know you can see the International Space Station. Mm-hmm. I've been at star parties where that was a bigger hit than looking at the telescope. And people are amazed when they can see the International Space Station.
Yeah, heavensabove.com is a very good website for seeing when bright satellites and the space station will pass overhead. I highly recommend that website.
I just got a question from Russell Babin to me, but it's asking about how far away the Hooker telescope is. That's actually my favorite term for it. It's the Hooker telescope. It's the 100-inch Hooker telescope on Mount Wilson Observatory. So as the crow flies, probably 20 miles, but you have to actually go up the mountain. So it's a good hour drive to get up there. But if anyone gets a chance to come to LA, go to Pasadena, go to the Mount Wilson Observatory, because you are able to walk the grounds. They have tours that are up there where you're able to see the 60-inch, the 100-inch, which is actually 101-inch, but shh. But you're able to get a tour and see the history and actually get to see the birthplace of astrophysics that we know it as today. That's where we're able to resolve and know that Andromeda is a galaxy and not a nebula, and see that the sun has a lot of magnetism going on, because we didn't know that at the time. So they're actually able to find these amazing things up there at Mount Wilson Observatory. And you can walk around the grounds for free if you want to, and I think tours are $10.
That's totally on my bucket list. I've never been up there. That has to happen.
Well, yeah, when you're out here in Long Beach in a couple months.
That's right, the AAS is in Long Beach. Yes, yes. Astronomers out there might know that the American Astronomical Society meets twice a year, and the Long Beach one is the next January meeting. Thousands of astronomers descend on one conference hotel.
Oh, it's January. Then you know what? It will be closed. We will not be able to get up the mountain.
No, sadness. Sadness. But if you're in the area, I'm sure we'll be doing a meetup. So go to meetup.com, look at CosmoQuest, and Pamela Gay and I will be in town, and we'll be hosting meetups and fun stuff.
Party like nerds.
Party like nerds. Let's get some more dramatic. Now we can see the dramatic cloud views. I've got Mark's view focused.
I'm going to mute my mic for a moment so everybody doesn't have to listen to the hairdryer cleaning off the fog from the front of the telescope.
Okay.
We got a question about, where did it go? Somebody asked about the chances of a transformer attack, which is awesome.
Slim to none.
It was, I don't remember who asked, because we've got, I can't remember who asked it, but somebody asked how far away the moon is, and I can't find it. But there's an app!
There is. I think it's around 383,000 kilometers right now.
So if you go to the Phases of the Moon app, which is an Android and iOS, it is exactly 366,358.61, 64, 67, 70, you get the idea, kilometers away. It's in a slightly elliptical orbit, and so it's always changing, but about 360,000 kilometers away. What is that in American people units?
I don't know.
I can't do the conversion.
Imperial units.
Let's change to metric, everybody. Come on, let's make this happen.
America, why you no use metric?
Why is America still using the British system of units?
Don't know.
And then, Emmanuel Data asked, how likely is it that the Earth will get or capture another moon? Is there a mass limit? It's not terribly likely. The Earth isn't exactly a beefy planet as far as planets go. Something like Jupiter and Saturn is much better at capturing moons. Now, our moon was most likely not captured. It's far too large to have been captured. It's like I said, a quarter of the diameter of the moon's diameter is a quarter of the Earth's diameter, and so it's far too large to have been captured. Probably formed in something known as the Big Whack, which is when something Mars-sized hit the proto-Earth, and
scientific terms.
Scientific, yes. You gotta love it. You gotta love it.
We had a solar system Punch and Judy show, and that's what happened as a result. Just beating, and there's the moon. Oh.
Ta-da! The Earth can temporarily capture something, but to capture it in a small rock in a permanent orbit is very unlikely. So we have the one moon. We are the one planet of the solar system that has only one moon. Pluto even has more than us. So.
It's true. So
Scott is showing us something. Sorry, my video's frozen.
It's the moon because I can't show you through a telescope. I can show you near a telescope, but here's the moon. Yeah, we have lots of props in here. It's awesome. What? If I can't show through, I might as well show you in near proximity, right?
And Damon Schooler says, happy birthday, Mark. It's your birthday?
In about 3 hours it is.
Awesome. Well, happy pre-birthday celebration.
Well, thank you.
Yay!
I was asked what I wanted to do for my birthday. I'm like, there's a public star party thing going on, and Scott's watching the moon, and I know tomorrow night there's going to be the virtual star party, so that pretty much covers my weekend for what I wanted to do.
Excellent.
We will steal your weekends. Thank you, astronomy.
Bryce Gregg asks, does anyone know what the largest object to hit the moon would have been? I don't know. I am blanking on how large of an impact it's suffered in the past. So the moon was formed around the time of late heavy bombardment, I think. And so it would have been hit by some rather large things that were left over in the solar system. Why are you laughing, Scott?
Because I have a bigger moon now.
But I don't know if I have an answer to that one.
Scott wins at the moon.
Anybody else? No, get away with it. And we've reached that part of the show.
Oh, I have been up for so long.
He's been awake for far too long.
I think now I'm officially a lunatic. I believe I can use that term correctly.
Excellent.
I know every time there's a near-Earth asteroid that comes closer to the moon than the moon's orbit, I usually run the elements just in case it might be going to hit the moon. I mean, it would be kind of cool to see. It'd be a 1 in a million shot, but as you can see the craters, it does happen occasionally. So
yes, it does.
It would be very cool if we had an asteroid hit the moon. Yeah,
I mean the solar system's fairly clean by solar system standards. It's nearly 5 billion years old now. Most of the junk has been clumped into specific orbits or places of orbits.
Don't talk about Vesta like that. It's not junk.
Don't get me
Vesta
started.
has feelings too, and we know that Vesta has feelings.
We know Vesta has feelings because it tweets about them. Also, if you're wondering, okay, so I just realized I'm waving this around. One of the demonstrations looks odd. One of the demonstrations that they did at the Franklin Institute was a penny orbit, and so I have a balloon here that they gave me, and a penny that I fished out of my boyfriend's little coin jar here. So I hope he doesn't mind. I've stolen a whole cent from him. Put the penny in the balloon, and now
wait, so when you blow it up, does that cause the inflation cost of the penny? And
what? No.
It was a bad joke. Don't mind me.
No cosmology jokes tonight. There's a first, blowing up a balloon on air.
On air.
On air, literally with air. Hopefully, okay. So we've got the penny in the balloon. This worked a little bit better with the marble, and you can get the penny. Probably can't see this in the video, but you can do this at home. Get the penny going around the inside of the balloon, and you can actually try and knock it out of an orbit. And it really wants to stay in an elliptical orbit, and then you can spin yourself around while you're spinning this penny inside the balloon. So the penny is the demonstration of the moon's orbit around the Earth. If you imagine the Earth at the center of this. And then you can spin yourself around like the sun. This was one of the demonstrations that we had in our second hangout of the day. We had this wonderful little girl named Abby, whose father let her be on the internet to demonstrate that for us when we were doing a hangout. Nope.
Something me and Scott were talking about yesterday is the moon was actually in the constellation Ophiuchus, which is one of the non-zodiac constellations. It's in Sagittarius right now. But the moon can actually pass through 18 constellations, I believe it is, at some time or another. Wow. It actually can transit some non-zodiac constellations like Auriga and Orion and Sextans, but Ophiuchus is. You might remember last year there was the big controversy about astronomers have discovered a 13th constellation. Just all of it. It's like yeah, but we've known that that everything the solar system ecliptic runs through that constellation for some time.
Yes. Right. It was some bizarre media cycle picked that up.
And that's the whole thing. When we talk about constellations, we're not talking about the anthropomorphized beings that connecting the dots. We're actually talking about regions of the night sky or anywhere on the celestial spheres we look up. We just break it up into sections. When we're talking about it in Sagittarius, we're not just talking about the stars that make up Sagittarius. We're talking about an entire region, whether there is a pinpoint a star there or not. And analogy I like to use is that here in the United States, like California, for instance, doesn't have a physical border. It's a political border. We've made it up, and it has this little region, but we do have cities that are physical landmarks with inside it. And so imagine the cities are the stars, but the entire region is going to be the state that you're in. So we do have regions of the sky, which are the constellations, but then you have the stars inside the constellation that we have familiarized with, and then you do have the ecliptic that makes up for the zodiac.
Pluto is off in that general direction in northern Sagittarius too right now. I believe the moon occults Pluto tomorrow. Of course, it's 14th magnitude, so good luck trying to actually see that against the lunar limb. But
one astronomer get it, Mike Phillips in North Carolina. He has actually got Pluto on air for us once, and it was fantastic.
Oh, very cool. I've seen it with the eyepiece, but that would be you'd need a very sensitive camera to catch it.
Yeah.
Well, I actually need to get running, guys. Since we've canceled, we're going to shut down in here. But I do want to take the time to thank everybody that's been involved from, 19 hours ago until now. Starting with Pamela and Paul from New Zealand. We had Peter in Australia that was having issues with his camera but was still sharing images with us, and Teal as well, all across the globe. I will thank everyone. Ahmed, Turkey. We had Christian and Jens in Denmark. David in UK. Shah, even though he did get clouded out in Malaysia. And then everyone else here in the U.S. Freddie, David, John, Mark, Nicole for being awesome sauce, and also Fraser in Georgia. I know Georgia wasn't able to get into the Hangout tonight, but she is doing an on-site outreach near Southern Illinois University, Edwardsville, at a custard stand.
At Annie's Custard! Yay!
Yay!
We love Annie's. They let us do star parties.
But honestly, everyone has been wonderful for getting this going on. We will have all the recordings up linked. I have them on my website right now, which is knowthecosmos.com. But please, regardless if it's the 22nd of September or not, just take the time to look up and think about the moon. We did just have Neil Armstrong, the first astronaut, pass away. The first astronaut to land on the moon pass away less than a month ago. Yeah. And it's a good way to reflect. It's the first human. It doesn't necessarily matter that he was born on this side of the planet, but we have brought a human being to this rock that is 380,000 kilometers away, and went there, brought rocks back. It's just phenomenal of what we can do if we actually apply ourselves and be curious and search after these things. So please take the chance to go out, look up, and be fascinated.
Be remarkable.
Be remarkable, everyone.
Be remarkable, Scott. Thank you, Scott. This is excellent.
Thanks.
Yes. All right. Good night, everybody.
Good night. All right. So I would like to call for anyone watching for last questions. Last questions in the if you're watching on Google+, you can leave a comment on the stream where we are broadcasting, and you can probably leave a comment on anywhere it's been shared, and I should be tracking those as well. But try and do it from the CosmoQuest broadcast stream. You can leave a comment there. You can leave a comment on the YouTube video, and you can use the hashtag #MoonHangout to ask us a question. We'll show some last gorgeous views of the moon. Do you guys have any other comments about what today's moon observing experience, or what it's like sharing these observing experiences online?
Well, it's the first time I've ever done it, and this is pretty cool. It worked out pretty well, actually.
Excellent, excellent. We're glad to have you and your moon views.
This may inspire me to get a better camera.
Oh, so Samir Hariri asked, what's a good USB camera I could use to stream the view from my telescope? Scott Lewis would be the person to ask. Scott or Fraser Kane, I will suggest that you ask one of them, unless any of these guys has a suggestion for a type of camera that they're using to stream. Anyone? No.
This is Freddy. I use a Celestron camera that you don't need to do anything. Just pop it in your telescope, and after installing the drivers, you are ready to go. but there are cheaper options in the market. You can get a webcam, used webcam like the QuickCam 3000 or something like that. You can find, or the one that David's showing there.
Yeah.
You can buy an adapter on eBay, and then you remove the lens of the camera and put the adapter in, and it will work like that. You just plug in your camera on the telescope. Of course, the telescope needs to have a tracking mount, maybe Altas or Equatorial. But after that, you are ready to go. And it's not easy at the beginning, I can tell you. But after a while, you learn every time you try to do something, and at the end, you get good results. And the best thing of all is your images, your pictures, and you enjoy doing those.
This is a $20 off the shelf webcam with just the eyepiece cement glued onto the front.
Wow. Okay.
And the lens I just took the lens off it and modified it to fit up. It does planetary and lunar work. It does double stars, bright double stars. It's not as good for doing nebula or really faint objects. But I run it with K3 CCD tools for image stacking and Registax and Photoshop for processing, and it works.
Cool.
There is also a group on the internet in Yahoo. Yahoo has a lot of astronomical groups, and there is a group dedicated to the use of non-conventional cameras for astronomy.
That's
so
awesome.
that means that you can see information there from a webcam or a Canon camera or any other camera. You can use your cell phone. They show information, all that kind of stuff, and you can learn from them. They are a very nice group of people.
Okay, so Yahoo non-conventional cameras. Search
yeah, it's QCUAAG or something like that.
Okay.
Yeah, I'm a member there.
Imaging and something else. Okay.
Cool. And if you want to get involved with the Hangouts, talk to Scott Lewis, because he's the coordinator for a lot of the virtual star parties, which happen Sunday nights. Oh boy, we got a couple more questions. Craig Williams was asking if the camera shake we were seeing was from the atmosphere or from the mount. Some of the shake, the back and forth shake, is probably from a little bit of wind on the telescope, but there's kind of a roiling fuzziness to it that we saw earlier, I think, in David's view, and that was the atmosphere. That's the turbulence of the atmosphere.
That was clouds.
Some clouds as well.
It's typically humid here, and it was the cloud cover, and just the moon is getting lower to the horizon now. It's about maybe 30 or 40 degrees above the horizon, so we're getting more turbulence.
Yeah, you get more turbulence as you get lower down. This is a well-known astronomical effect called seeing, S-E-E-I-G, seeing. Larry says the moon rocks. That's totally true. Let's see less. Larry Hudgens asks, what percentage of the moon has been mapped, and is there evidence of ice, or is it speculation? I would like to say, I know that the moon has been mapped with the best resolution by the Lunar Reconnaissance Orbiter, and that's a lot of what we have up on the Moon Mapper site. We have that data. I don't know if the entire surface has been mapped by LRO yet, but it's been mapped at the entire surface has been mapped at lower resolution. And there is evidence of water ice from the L-Cross mission, which shot a projectile at the South Pole, at a crater in the South Pole, and detected water ice in the plume. So there you go. And there's a couple of other experiments as well. The Chandrayaan, I can't remember the name of it. There was another probe orbiting the moon that detected evidence of water as well. So the moon. So our understanding of the moon is constantly changing, even though it's this thing that we've seen in the sky for all of human history, which is pretty fascinating. Okay, any last thoughts before we sign out? No?
No.
Okay. Those few last shots. So I wanted to thank everyone for watching, and like Scott said, all of the amazing astronomers who shared their view of the moon with us. So I'm showing David's right now. And I'll scoot over to Freddie Diaz's view. We have John Kramer as well. And we had Mark Bernhardt's moon, but it seems to be covered in clouds, so it's just dark now.
I think that's going to be the case here pretty soon too.
Yeah, it's pretty cloudy on a lot of the East Coast too. So I'm glad you were able to join us. If you're clouded out and couldn't go out and see the moon yourself, and if you can go out and see the moon yourself, go outside right now and look up. Like there's no excuse. You can go out. Now. Whether you have a telescope or binoculars or just use your naked eye, take a few minutes, look at the moon, and share that experience with everyone. Oh, wait, we got Mark's dramatic cloud moon view one more time. I love that.
We need the howling.
Really cool. Somebody howl. I'm not doing it. Okay.
No takers.
No takers. I'm not doing it.
I could call my dog back out. She would probably howl.
Hey, we'll say Halloween, the 31st. I think there's a full moon on that night.
Ooh.
I think
maybe a couple days earlier.
I think it's a few days earlier because it would be a blue moon, and I know we're not having another 2 in 1 month for a couple of years. So I think it's a few days earlier.
Well, it's a great outreach opportunity for Halloween trick-or-treaters to show them the moon.
I usually do that every year. I put my telescope out in the front driveway and show people whatever there happens to be.
Lots of fun.
That's awesome. Sidewalk astronomy for the win.
Right.
I love it. All right. Well, thank everyone. I am Nicole Bellucci again from CosmoQuest. Go check out. We have Hangouts. We have data of the moon from the Lunar Reconnaissance Orbiter, and you can take part in the science and check that out. So thank you, everybody.
All right. Thank you.
Thank you, Nicole.
Thanks,
all right. Thank you. Bye-bye.
Thanks. Signing out.